What is the difference between latch and flip-flop?
The main difference between the latch and flip-flop are latches are generally level triggered, whereas the flip-flops are edge triggered.
Can you explain what is metastability?
Metastability, when setup and hold violation is done, then output of flip-flop in between zeros and 1, it's not properly 0 or 1, it's just hang in between those high and low.
The output is unpredictable.
Unpredictable.
Is there any remedy to avoid the race around condition? Adi?
Basically, we use master slave latch to avoid the race around condition, and also there is to increase the propagation delay, which it is not used in the practical, but in practical we will use flip-flop to avoid the race around condition.
Now, Adi, you had 2 points about the combinational circuit and sequential circuit.
So she told all the points.
What is the difference between combinational circuits and sequential circuits?
In combinational circuit, output depends only on its present input. In sequential circuit, output depends on its present input as well as previous output state. In combinational circuit, there is no memory element and as well as there is no feedback. In sequential circuit, we have memory element as well as feedback. In combinational, we don't have any clock. Output is generated as soon as we change the input. But in sequential circuit, we give the clock trigger and output is generated when clock is triggered. Combinational circuit, it's faster because no clock in there. Output is generated quickly, and in sequential it's a bit slower because output waits for clock triggering.
Now, Adi, you had few points about the combinational circuits and sequential circuits.
Like in combination circuit, the blocks we use are the adder, subtractor, mux, demux. Whereas in sequential circuits, the blocks we use are the flip-flops and latches.
As she told, combinational circuit doesn't have any memory, and sequential circuit has the memory. How that memory is basically, created?
In sequential circuits, the latches or flip-flops stores the memory. In combination circuit, there is no triggering. So
No. Actually, the memory comes because of the
Feedback.
feedback connectivity, right? Now, coming to the combinational circuit, we have very important combinational circuit that is known as
mux.
What are the main applications of mux, Adi?
The mux is main used in the ALU, arithmetic logic unit. When we are given an input, the output will be in operation. Like if there is 8 into 1 ALU, so we can store like adder, subtractor, comparator, and XOR gate or something. So when we are giving an input at 4 bits, the operation will be.
What is the relationship between the inputs of a mux and selection line?
When we are taking the 2 power n number of inputs, the selection lines required are n.
So there is a relationship like if you have 2 raised to power n inputs, we will need n selection lines, right? Okay. So suppose now I want to design a 1000 cross 1 mux. So how many selection lines will be needed?
10.
10. Okay. How did you calculate it?
2 to the power n.
Okay.
1 0 more than 1000
More
called
than
2 to the power 10.
There is the fundamental building block for sequential circuit, that is latch and flip-flop, as you told. What is the difference between latch and flip-flop, Adi?
The main difference between the latch and flip-flop are latches are generally level trigger, whereas the flip-flops are edge trigger. And latches are also fast. And for flip-flop, we will use master slave latch. So generally, it takes 2 latches to build a flip-flop. So the power consumption also is less in the latches and power consumption is more in the flip-flop. As latches are level triggered, the active area is the more, so the noises are also more in the latches, whereas in flip-flops it is the edge trigger, so it will be only the active for slight second, so the noises will also be less. And the main comparison will be in latches, the race around condition will be occurred. By using the flip-flop, the race around condition can be removed.
What do you mean by race around condition, and it occurs in which latch?
Race around condition usually occurs in JK latch. It's due to the toggle mode. In toggle mode, output is toggling from 0 to 1 continuously. In race around condition, the output is not staying stable, it's continuously moving from 0 to 1.
Is there any remedy to avoid the race around condition, Adi?
Yes, sir. Basically, we use master slave latch to avoid the race around condition, and also there is to increase the propagation delay, which it is not used in the practical, but in practical we will use flip-flop to avoid the race around condition.
In sequential circuit, there is phenomena of timing constraint.
Yes,
We have setup and hold time, right?
yes, sir.
Can you explain it? What are the setup and hold times?
Setup time is the minimum amount of the time required when before the active clock edge, where the data should be stable so that the flip-flop can latch the data correctly. And whereas the hold time, it is also the minimum amount of time required after the active clock edge so that it can check the captured data is not corrupted.
When this doesn't meet the requirement, then does it occur any problem?
Yes, sir. When the setup and hold violations occur, we can face the condition called metastability.
Can you explain what is metastability?
Metastability, when setup and hold violation is done, then output of flip-flop in between zeros and 1, it's not properly 0 or 1, it's just hang in between those high and low, and this situation is called metastability.
The output is unpredictable.
Unpredictable.
So how can we avoid the metastability condition?
We need to
Fix
the fluctuation in input should not be near the clock triggers.
Yeah, very nice, right? Means we should not change our input nearby the clock is. There should be a time lag, right? Okay.
Clock period should be larger, and we can also use synchronizer, flip-flop synchronizer.
Yeah, synchronizers. So generally, which synchronizer we use?
We use T-latch.
Two flop synchronizer.
Two flop.
Okay.
By cascading the two flip-flops.
So define FSM, finite state machine.
RFSMs, Mealy and Urey machines are FSM. In Mealy, output depends on output of Mealy machines depend on its present state and input, wherein Urey machine output depends only on its present state.
Okay. Suppose I need to represent 100. Okay. So how many minimum bits will be required when this number is represented in unsigned form? Okay. And if suppose you want to represent in 2's complement form, then
we will require 8 bits.
8 bits. Okay. Why this 1 bit is extra?
1 bit is for the signed.
Signed. Okay. Very nice. Okay. Because for 2's complement, this is a signed number, and for any signed number, we will need one extra bit reserved for signed. Okay. That will be MS bit. Okay.